Okay, moving on in morphology. So before we even start talking about the brain, I want to introduce you to some important behavioral results about morpheme processing. So remember our two theories. We have the decomposition theory and the storage theory. And so the decomposition theory basically implements a morpheme lexicon, and the storage theory implements a word lexicon. And the two lexicons have different similarity relations. And similarity matters for priming. So the nature of these similarity relations makes different predictions about what types of priming effects we might observe. So let's just kind of refresh what we learned earlier about priming. So in a lexical decision task, which is the most commonly used experimental task when we're studying lexical access, the retrieval process of finding word representations in our brain, we know that semantic similarity helps. That is, it makes you faster. So if you get doctor and then nurse as the item that you need to press a button on, so you say, is this a word or not? The thinking is that doctor activates nurse, spreading activation, and therefore when you get nurse, it's already been a little bit pre-activated by the previous word, and so you're faster. Phonological similarity, so sound similarity or form similarity, is more complicated. So this is something that we didn't get into very much before. So turns out that it has kind of a dual nature. So it can be helpful if you've only had a little bit of time to appreciate the first word, that is the prime. But if more time passes, it actually can become hurtful or inhibitory. So here's kind of the idea, and I'm going to give you a picture to accompany this as well. So imagine that you're, let's just say, hearing turn, okay? So as you start hearing turn, that stimulus is going to activate not only the word turn, but also other words that start the same, like, say, turf. And so now, as you're hearing turn, if very quickly after the onset of turn, you get the target turf, then you might actually be faster because the previous word served to activate that other representation, kind of the same way that happened in the case of semantic similarity. However, if more time passes in such a way that you have now fully heard turn, you've had a lot of time to appreciate that representation, and your brain has decided that, yes, this word is turn, it is not turf, okay? So in some sense, you've already rejected that alternative representation, and then you get turf, your brain can go kind of like, whoa, I just decided that that word wasn't turf, and now you're giving me turf. You can get kind of confused. So if more time passes between the onsets of the two words, then phonological similarity or form similarity more generally can actually be inhibitory. So phonological priming effects are a little bit complicated. So let me just give you a picture for this. So ultimately, recognizing turn requires rejecting turf. So if a longer interval passes between before the target is presented, then turf might actually elicit some inhibition. So here's kind of a picture of lexical activation, or the sort of subcomponents of lexical access that most people would more or less agree on. Of course, there's lots of different theories that differ in the details, but what I'm showing here is a timeline. So imagine here the first point would be 0, so that would be the onset of the word, and here it would be onset of the prime, so the first item in a priming paradigm. So let's imagine that's turn, like I just used in the prior example. So when you're perceiving this word, turn, there's a rush of activation across your mental lexicon, and I'm showing that rush of activation as these lines that like sort of start shooting up. So that would be the first stage, this kind of like activation that's spreading across lexical entries. And so now, so we imagine that that's the prime, and so now if the target turf, like I was just sketching is presented very quickly, very shortly after the onset of the prime, then you could get a facilitatory effect for that target. So a faster button press time than if it was preceded by something totally unrelated, because you would get that kind of like boost of activation. It's still benefiting from the phonological neighbor. And so turf would be faster in this situation than if it was preceded by like clock or something that has nothing to do with turf, either phonologically or semantically. But if more time passes, so just saying the same thing twice, but now with the picture, if more time passes, so it's like somewhere out here, and now I'm like not giving you any specific milliseconds, just kind of relative timing. So if the target is presented after your brain has kind of rejected turf as the right representation for the word. So the idea is that you first have this rush of activation, then these representations have to kind of duke it out. They have to kind of like compete with each other, like, well, which one of us is really the best match to the stimulus that we perceived, and then the best match will be selected as the winner. And so if that has happened and turf has already been kind of either actively inhibited or its activation level has just started to kind of dwindle, then at that point you might not get any priming anymore, or you might even get an inhibitory effect, which would be an actually slower reaction time to turf in this situation than if it was preceded by something totally unrelated. So that's kind of the, the complicated nature of form-related priming. We have to keep this in mind because morphologically related words do have a form similarity. So in order to kind of make predictions about morphological priming, we have to have some understanding of what just form priming looks like. Okay, so a little bit complicated. But in contrast, and so relief, identity priming is straightforward. So this is repetition priming. You get exactly the same word twice. So this is like the dog priming, and it's kind of straightforwardly facilitatory. So the second presentation of a word is much faster, since that very word was just actually recognized as the right match during prime processing. So you get dog and you're like, yes, dog, this is the right representation. And then you get it again, you're like, okay, whoa, this is very easy because I literally just accessed this representation. Okay, so that's the basic landscape of priming priming effects, and the basic nature that different types of similarity and identity impact priming. So now we're going to go into our models and test the prediction. So under the decomposition theory, morphologically related words should elicit identity priming, at least in some form, because you are repeating the same morpheme. It's a fundamental prediction. Whereas under the storage theory, there is no identity relationship between morphologically related words. So I'm using the terminology of the other theory. I hope that's not too confusing. But the little morphological family here that I've circled that isn't really a family in this theory, all the priming effects that we should elicit between these words should be explainable just in terms of the similarity relationships that these terms have to each other. So they're phonologically similar. They have a lot of phonological overlap, in fact, and they're semantically similar as well. They all talk about magnets in some sense. So we should be able to explain the priming effects by referencing these similarity relations. Okay, so how does that shake out? I'm going to show you a classic study. It's 20 years old now, but it's a really good one, by Kathy Rassel and colleagues who tested these kinds of predictions in a behavioral priming experiment. So get a lot of information from this study. It's a little bit complicated, but I want to show you how we can learn a lot without even measuring the brain. I mean, all this stuff is still obviously happening in the brain. So, so this group tested the priming effects elicited in lots of different situations. So in one case, we have the kind of doctor-nurse case. So here it is, the example is cello, violin. So this would be meaning similarity. So these are two musical instruments. This is a visual paradigm. So both words are presented visually. The first one is in lowercase. The second one, the target item, is in uppercase. That's just to make sure that there's no kind of perceptual level priming when we get to the cases where there's actual form overlap. So basic meaning similarity case, cello, violin, gives us a measure of semantic priming. And then we have the form similar or phonologically similar case, so something like typhoid, typhoon. That's their example. So there's of course lots of different cases of these relations within the experiment. And then there's a really crucial condition. And this condition is a situation where there is both form similarity and meaning similarity, but it's not a case of morphological relatedness. So this is a little bit difficult to find in language, although we do have cases like this, like ritzy glitzy, for example. The example here is screech, scream. So these two words sound similar, and they also have a somewhat similar meaning, but they're not morphological relatives. Okay, so here's a case where we can really measure, like, how do these two different types of similarity combine, you know, independent of a morphological relation. So that's going to be really crucial. So we're going to want to know, like, okay, when you actually do have that morphological relation, does it look just like this, which, you know, the storage theory could explain, or is there something special about that? So that's going to be important. And so in fact, next we do have that morphologically related case, so adapter, adaptable. So now we have the morpheme adapt that's shared between these two items, so the prime and the target. And then finally, a crucial identity case. So this is just a totally straightforward identity priming. Church, church should give us like a very straightforward facilitatory effect. Okay, so lowercase visual prime followed by uppercase visual target. They're doing lexical decisions only to the second word, so that's the target. So they're pressing yes if it's a real word in English, no if it's not a word that they know in English. And the priming is assessed with respect to unrelated controls as a standard. So each of these will also have their kind of unrelated pairing. I don't have all the unrelated stimuli here, but imagine a word that has nothing to do with violence, you know, table violin, something like that. So it needs to be not related in sound, not related in meaning, not related in any way. And then you're comparing the response time to violin to the response time you get when there's just something totally unrelated preceding. So this is like a standard methodology in priming studies. Okay, so now let's see what happens. Actually, we're not yet going to see what happens because they had an additional factor that was manipulated. And so now this is the reason why I walk through the kind of complicated effects of timing on phonological priming in particular. So the time between the onset of the prime and the onset of the target. So we actually have a technical term for that interval. It's called stimulus onset asynchrony, SOA. So when people talk about SOA, they talk about that interval. So specifically, so interval between the onset of the prime and the onset of the target. So here it's making super explicit. So if there is 200 milliseconds between the onset of the prime and the onset of the target, like cello, violin, then it would, SOA would be 200 milliseconds. So that is something that they also varied. And the reason for that is that priming effects differ in how fast they develop. So how quickly you can get the priming effect after the onset of the prime. So that means, like, you know, can you give the target super quickly after the onset of the prime and observe the priming effect? And also how long they last. So some priming effects die quicker than others. And we'll learn more about that later. In particular, identity priming effects are super robust and long lasting. And basically, all other priming effects kind of die down relatively quickly. So in this study, they used 3 different SOAs in order to assess the speed at which the priming effects develop and also how long they last. And so specifically, they used 43 milliseconds. That's super quick. In fact, that's quick enough that the subject won't really be conscious of even having seen the prime. The second one was kind of a mid-latency one, 73 milliseconds, still really fast. And then finally 230 milliseconds. So that's an SOA that allows you to like fully appreciate the prime stimulus. Okay, so here was their question. So how much faster or slower were subjects' lexical decision times to the related targets than to the unrelated targets? And so here, positive numbers are going to be positive priming. So that means that the related condition was faster than the unrelated condition. And the negative numbers are going to be suggestive of inhibition. So you were actually slower in the related condition than the unrelated condition. So we're going to be showing subtractions between unrelated, so unrelated minus related. That's what these numbers are going to be referring to. And I'm going to visualize all the results at once, but then we'll go through them one by one because we want to evaluate the question. To what extent can we explain the morphological priming pattern by just reference to the similarity priming? Okay, so here's the full graph. So below here you have the SOA. So now that's the interval from the onset of the prime to the onset of the target. Remember, it's visual. So that's the fastest one, that's the mid one, and then that's the longest one. And here we're plotting on the y-axis the amount of priming that was elicited. Okay, so big numbers are lots of priming. The negative numbers are kind of inhibitory patterns. The stars on the data points show us whether the results were statistically significant. So psychologists like to use these stars to annotate it. So two stars is more significant than just 1 star. Okay, so let's go through this. So first of all, so here's the identity case. And so what we see here is that on all of the SOAs, so that's the shortest one, mid one, longest one, you get a straightforwardly positive priming effect. And so that's what we would expect. So, you know, identity priming is robust and positive in the sense that it helps you, it doesn't hurt you, okay? And next we have the morphologically related case. So now you can see that it's a little bit lower than the identity priming, okay? So it's not the same, but it is overall a similar pattern. So here we also have positive priming all around, okay? So it's a pretty similar pattern. And now the crucial comparison case is this screech-scream case where we have sound similarity, form similarity, and we have the semantic similarity, just like in the morphologically related case, but it's not morphologically related. So now, if the morphological priming effect was explainable as an instance of just this kind of cumulative effect of sound and form similarity, then it should be pretty similar to screech and scream. But instead of this kind of overall positive priming paradigm, pattern, the screech-scream priming looks to be more slowly developing. So you don't get a reliable priming effect until the longest priming effect. And in fact, at that point, it looks similar to the cello violin priming, so just pure semantic priming, so that it's reasonable to think of this as a reflection of the semantic similarity of screech and scream. So just like the purely semantically related case, screech-scream priming shows a slowly developing priming effect, but nothing in the shorter SOAs. And then finally, when we have only a form relationship, no semantic relationship, in this study, there was really no significant priming. So that actually suggests that there is kind of an interference between the two forms that's kind of like inhibiting any kind of facilitatory effect from emerging between the fact that you are, in some sense, seeing similar forms twice, which could be facilitatory, but just isn't. So, you know, the trend is more towards inhibition than towards positive priming. So crucially, what we see here is that it is really difficult to try to explain the pattern that you get for the morphological relatives just purely in terms of similarity. So if you put cello and violin and typhoid together and sort of combine those two effects, you're not going to get up here. And then with the screech scream case, they actually show like, oh, in a naturally occurring pair, when phonological and semantic similarity co-occur, doesn't co-occur often, but when it does, that also looks different from the morphologically related case. Okay, so that's an example of behavioral data that tells us that the fact of morphological relatedness tends to pattern similarly to the fact of identity, so church in this case, and not similarly to the fact of combined form and meaning similarity like screech scream. And that's a prediction that, that's an outcome that follows straightforwardly from the decomposition theory, but not so straightforwardly from the storage theory, where everything really should just reduce to these similarity relations. So it seems that our brains do perceive morphemes. We do seem to compute with morphemes, not with whole words. And so next, the question I want to ask is when and where in the brain this kind of morpheme spotting occurs.